Okay, I hope that all of you were able to watch the 9-3 notes that you watched either, what was that, Tuesday night or Wednesday night, depending on when you took the quiz. Graphing with transformations. We're going to continue graphing, only now we're not going to have the transformations readily available to us. We're going to have to deal with some factors. The rational functions that we've been dealing with are equations of the form f of x, which is equal to a of x over b of x, where a of x and b of x are both polynomial functions, and b of x is not equal to 0. Because if the denominator is equal to 0, everything's undefined, and that causes us problems in the math world. To graph a rational function, it is helpful to locate the intercepts, both the x and y intercepts, if the problem has them, and the asymptotes. Again, if the problem has them. Most have asymptotes and most have intercepts, but some don't. Zeros. Zeros occur when the numerator equals 0. When the zeros are real, they're also known as the x-intercepts. So those will be helpful. Vertical asymptotes occur when the denominator equals 0. Remember, when the denominator is equal to 0, then the function is undefined. So those locations where the function is undefined, those are going to be vertical asymptotes. There is one case where it's not a vertical asymptote, it's something else. It's a special situation. We'll talk about it in a little bit. Horizontal asymptotes, there's 3 different situations for the horizontal asymptotes. We're talking about the degree. So remember, the degree is the highest power on the variable. If the degree of the numerator is less than the degree of the denominator, so I call that bottom heavy. So that's like an x over an x squared. Then the horizontal asymptote is y equals 0. Okay, so if the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y equals 0. If the degree of the numerator is equal, sorry, this is equal. If the degree of the numerator is equal to the degree of the denominator, so say you have a 2x cubed blah, blah, blah over a 4x cubed blah, blah, blah. So in this case, the degrees are equal. Then the horizontal asymptote is y equals leading coefficient of the numerator divided by leading coefficient of the denominator. So in this case, it would be y equals 2 over 4, also known as 1/2. And then the challenging one, if the degree of the numerator is greater than the degree of the denominator, so it's top heavy, so it's something like an x squared over x, then there is no horizontal asymptote. If the degrees differ by 1, so an x squared over an x, or an x cubed over an x squared, the difference is 1, then there is an oblique or a slant asymptote. And the thing that makes these challenging is that we have to use long division to find the equation of the asymptote. So 3 scenarios. If the function is bottom heavy, meaning the degree of the denominator is greater than the numerator, y equals 0 is the horizontal asymptote. If they are equal, if they're equal, then it's leading coefficient of the numerator divided by leading coefficient of the denominator. Again, y equals that. And then if it's top heavy, meaning the degree of the numerator is larger than the degree of the denominator, there's no horizontal asymptote. If they differ by 1, then we will have an oblique or a slant asymptote. All right, so how do we find these? First thing you're going to want to do is you're going to want to factor. I told you, new best friend is factoring. It's not going away anytime soon. All right, so we've got x squared minus x minus 6 over x plus 1. So we're going to factor that numerator. How does that factor? Well, we've got an x and an x. Two numbers that multiply to 6, add or subtract to 1. We're going to go with 3 and 2. I need a negative 1, so I need a negative 3 plus 2. And then that is divided by x plus 1. So that's the factored version. Now, what is the degree of the numerator? The degree of the numerator is the highest power on a variable. In this case, it is 2. What's the degree of the denominator? That's the highest power on the variable. What's that imaginary number there? It is a 1. So this one is top heavy. The numerator has a larger degree than the denominator. Okay, so what does that mean? The top heavy scenario means that we are not going to have a horizontal asymptote. If the degrees differ by 1, which they do, 2 minus 1 is 1, we are going to have an oblique asymptote. So we're starting off with the hard one first. Now, what other things am I asking about? We'll do the oblique asymptote last. X cannot equal. What numbers or what values of x are not allowed? Well, those are the ones that make the denominator equal to 0. So what number makes x plus 1 equal to 0? Negative 1. So x cannot equal negative 1. The function is undefined there. So what is that going to look like? That's going to be in the form of a vertical asymptote. So at x equals negative 1, we will have a vertical asymptote. Again, the vertical asymptote is where the denominator is equal to 0. And then what? Then we have the zeros. The zeros are where the numerator is equal to 0. So if we look at our numerator, when will that equal 0? When does x minus 3 equal 0? At 3. And when does x plus 2 equal 0? At negative 2. So the zeros are 3 and negative 2. If I change this question slightly and I asked you for the x-intercepts, you would say 3 comma 0 and negative 2 comma 0. Zeros are the x values, x-intercepts are written as ordered pairs. Okay, so how about this oblique asymptote? We have to do the long division, and hopefully you remember that from last year. X plus 1 divided into the x squared minus x minus 6. So x times what will give us x squared? X times x will give us x squared. Then we multiply. X times x is x squared. X times 1 is 1x. Then with long division, we always subtract, and I always put a giant subtraction. X squared minus x squared is 0. Those first terms will always drop out. Negative x minus negative x is negative 2x. And then the minus 6 drops down. Then what? X times what gives us negative 2x? X times negative 2. Multiply, we get negative 2x. Multiply again, we get minus 2. And again, that's a giant subtraction. Negative 2x minus negative 2x is gone. Those get eliminated. Negative 6 minus negative 2 is really negative 6 plus 2, which is negative 4. This is the remainder. Doesn't mean anything. The thing that we want is this value up here, the dividend. Y equals x minus 2. Y equals the x minus 2 is our oblique asymptote or our slant asymptote. And you'll see more of what those look like when we actually graph some things. Now we're just trying to find some of the pieces. Okay, let's look at the next one. So we've got f of x equals x minus 7 over x squared minus 1. First thing we want to do is we want to factor that. So we'll get x minus 7, we'll get x minus 1, and x plus 1. What's the degree of the numerator? Well, it's this little imaginary 1 on the x. What's the degree of the denominator? It is a 2. So what does that mean? That tells us about the horizontal asymptote. When it is bottom heavy, so when it is bottom heavy, the horizontal asymptote is just y equals 0. What values of x make the function undefined? What can x not equal? X cannot equal 1. X cannot equal -1. So what does that mean for us? That goes with the vertical asymptotes. The function is undefined at 1. The function is undefined at -1. So we will have vertical asymptotes in our graph. Since we have a horizontal asymptote, we are not going to have an oblique asymptote. It's possible with some complicated kinds of things, but we're not going to get that complicated. So we'll either have a horizontal or an oblique, never both. And then last thing are the zeros. Remember, that's where the numerator is equal to 0. So when does x minus 7 equal 0? It equals 0 at 7. Again, if I asked you a different question, what are the x-intercepts? You would say 7, 0. We could also find the y-intercept, which I didn't include on here, but the y-intercept, remember, is at 0, something. Plug in 0 for x, you get -7 over -1, which is 7. So at 0, 7, you'll have a y-intercept. Kind of coincidence that the x-intercept and the y-intercept are reverses of each other. Doesn't always happen that way. All right, next example, we've got 2x squared minus 5x minus 3, and then we've got x squared plus x minus 6. So if I factor this, we get 2x and an x. I need a 3 and a 5 in the middle, so that'll be a 3 and a 1. I need a -6 plus 1. And then in the denominator here, I'll need an x and an x. To get a 6 with a x in the middle, I'll need a 3 and a 2. I'll need a +3 minus 2 to get me the +1. The degree of the numerator is 2. The degree of the denominator is 2. So when they're equal, the horizontal asymptote is the leading coefficient divided by the leading coefficient. So in this case, that's equal to 2 over 1, which is just 2. Zeros, where does the numerator equal 0? Well, that's when 2x plus 1 equals 0 at -1/2, and at x minus 3 equals 0, also known as 3. Vertical asymptotes, that goes hand in hand with what x cannot equal. That's where our denominator is equal to 0. What values make the function undefined? That would be at -3 and 2. So we will have a vertical asymptote at x equals -3, and we will have a vertical asymptote at x equals 2. Since we have the horizontal asymptote, we will not have a slant asymptote. And here is the special case. So if we look at this one and we factor it, we get x minus 4 times x plus 1 over, in the bottom we'll get x plus 6 and an x plus 1. Okay, so what values make this function undefined, where the denominator is equal to 0 at -6 and -1? But if you notice, the x plus 1 and the x plus 1 cancel. So what that creates is something called a hole. At the point where the -1 would have been, we will have a hole there. We will not have a vertical asymptote. So it's kind of like you've got a graph, and then you've got a hole, and then the graph continues. It's just going to be an open circle where the point -1 comma blank would have been. This is called a point discontinuity. It's something that in pre-calculus and calculus you will determine it to be a removable discontinuity, because basically I can take a point, redefine it, plug the hole up, and I've removed the hole or the issue that becomes a problem for us in calculus. Vertical asymptotes are considered non-removable